We're going to talk today about variables and expressions, and that's vocabulary that you need to know. A variable is a letter or a symbol that represents a value that can change. Now, that can be an X, it can be a Y, it can be any letter, or it can be a question mark, it can be a square, it can be a circle, whatever. Those are variables. A constant is a value that does not change. So when you have just a number, that is a constant. A numerical expression is made up of just numbers and or operations. So 6 is a numerical expression. 6 plus 3 or 6 times 2. Those are all numerical expressions. An algebraic expression has to contain a variable. So it's a variable. It can have constants and or operation symbols. So 4x plus 3 is an algebraic expression. So here's some examples of expressions and equations. What do you notice is the biggest difference? I'm hoping that you notice that an equation is going to have either an equal sign or an inequality sign. It's basically two expressions that are joined together by an equal sign or an inequality sign. Expressions do not. Now, that's huge. When I say an expression, I want you to know that there should not be an equal sign or an inequality sign. You can do different things with them. Expressions you can simplify, so you can combine like terms, do the distributive property, anything you can to make it in a simpler form, reduce fractions, whatever. Then you can evaluate an expression. So for instance, here's an expression, 2x plus 3, and I'm going to evaluate it when x equals -2. So I am giving you a value to put in there for the variable. So you would simply take the -2, substitute it into the equation, and work it out. So this would be 2 times -2, which is -4, plus 3, -4 plus 3 equals -1. This would be the value of that expression. So I evaluated it. Okay? Now, with an equation, you can simplify an equation. So again, you can do the distributive property, combine like terms, reduce fractions, whatever. But then you can solve an equation. Because you now know what this equals, now instead of me giving you a value for x to use in there, you're going to tell me what the value of x has to be in order to make this work. And just using a little bit of mental math, I'm thinking, what plus 3 gives me 9? Well, that's going to have to be 6 plus 3 equals 9. And then 2 times what equals 6? So by just using a little mental math, I can tell you that x is equal to 3. Okay? We need to be able to translate from words into expressions or equations so that we can work with them. So I put the 4 operations over on the side, and then I put some problems over here. What I would like for you to do right now is pause the video. What does the word sum represent? What operation? I'm hoping you know that that is addition. And what words could we use to represent addition? We could say a number increased by 3, 3 more than the number A plus 3, T more than the number 10, 10 increased by T. So I want you to kind of play around with words and think of creative ways that you can represent an operation in words. All right? Difference should be subtraction. Okay? Some number decreased by 6. 6 less than the number x. This one would be 5 decreased by y, or a y less than the number 5. You have to be very, very careful when you're using subtraction because the order makes a difference, and that is confusing sometimes for people. So pay close attention to that. All right? Product is multiplication. Now, in the old days, you guys used to use an X for multiplication. We're not going to do that anymore. Okay, so we're not going to use this anymore like that. We instead are going to use a dot or a little asterisk. Sometimes when you're using a computer or something, you'll do *6, and that's the little asterisk, and that will be multiplication. Okay. You also sometimes will just have the number and the variable right next to each other. So here, 2 times the number x, twice the value of x, 3 times the number s, 3 times, 3 times as many s. I'll have to think of some more creative ones. All right. Next is quotient. Quotient is division. And you'll also see a bar like this or a bar like this. Okay, both of those mean division. And I think I've used 2 of them here. Okay, again, quotient is one of those where the order is crucial, so the way you say it is very important. We might say some number n divided by 4, n cut into 4 pieces, c divided by 8. If I said 8 divided by c, those would be switched. So again, the order is very important. Now here's another page where I want you to stop. I want you to stop. I want you to evaluate each of these 6 expressions using these values for the variables. Okay? So stop the video, do this on a separate sheet of paper, and then we'll check it. Now check your answers. Okay? 2 plus 6 is 8. 6 minus 2 is 4. 2 times 6 is 12. 12 plus negative 4 is 8. Remember, different signs. Subtract, keep the sign of the larger. 12 divided by negative 4 is negative 3. And 12 minus a negative 4. I don't know if you all remember this from pre-algebra, but this is a plus. That double in the negative there is a plus. All right, we're going to work on a little word problem here very quickly, being able to take words and put it into an expression or an equation. Tina is 4 years younger than her brother Jeff. So it's asking us to write an expression for Tina's age if Jeff is J years old. Okay, so Tina is 4 years younger. So J is Jeff. And what do we do to represent 4 years younger? That would be minus 4. There is an expression. Tina is 4 years younger than her brother Jeff. How old is Tina when Jeff is 15? So now what I'm asking you to do now is evaluate this expression using the values that they gave us. So we're going to put a 15 in here. So 15 minus 4 equals, so Jeff is 15. That means Tina is 11. If Jeff is 20, 20 minus 4, then Tina is 16. If Jeff is 58, then 58 minus 4, Jeff is 54. And that's how we use expressions.